So those are some aspects of engine terminology. One final closing statement that I will make, I'm going to ask you a question, and that question is, and I'm not sure if you'll even know what this toy is, but what do Tickle Me Elmo, and if you have not seen Tickle Me Elmo, I would recommend that you right now go and type it into Google and try to see what Tickle Me Elmo is. On YouTube, you'll see a video of Tickle Me Elmo. It's a toy that was very popular years ago. For those that grew up on Sesame Street, they will know who Elmo is. So what do Tickle Me Elmo intercontinental ballistic missiles and your car have in common? So that's a question to you. What does Tickle Me Elmo, intercontinental ballistic missiles, and your car have in common? The answer to that is embedded processors. These are single chip computers that are pretty much everywhere now. They're inside of household appliances, inside of a bread maker, inside of toys, they're inside your vehicle, they're everywhere. But they're essentially single chip computers There are popular ones now for the home hobbyist movement, Arduino, Raspberry Pi. I've myself played around with one from Intel, which was the 8031 or 8051 family, and that has evolved now where they have the double EEPROM embedded within the device, and they would have all the interrupts, analog to digital converters built in. But these are in all three. And I read an article a number of years ago about the Corvette, and it said that 30% or 35% of the cost of a new car are in electronics. Now, I would assume that since then, and I read that article, it was probably in the late 90s, that number is probably even higher, given all the electronic gadgets that they now put within cars. The Corvette at the time, a very popular car in North America, what they call a muscle car because it goes so fast, but a Corvette has around 30. And so this is what helps us have more efficient engine operation, our airbags, all of those are operated using embedded processors. But essentially what the embedded processor does, instead of having to have a central processor and a hard drive or a human interface like a keyboard and all the other aspects, everything is embedded into one single chip. And so within this chip, you'll have a region for the CPU, the central processing unit. You'll have interrupts. And what the interrupts do is you can have a voltage pulse, typically TTL, which is 0 to 5 volt. It could be lower. But you'll get these interrupts, and they can stop your program, and then you can go to another part. So it's kind of like an interrupt for your program. You also have analog to digital converters embedded in here. You will have RAM. So that's random access memory where you can put information. The new ones have double EEPROM, so electronically erasable programmable read-only memory. I believe that's what the P was for. The one that I played with, I had to use ultraviolet radiation to erase my EEPROM. It wasn't a double EEPROM, it was an EEPROM. You also have timers and clocks, so you can have timers and interrupts, all other types of things like that. And you can also have D to A. So with the A to D, what you have here are analog input sensors. So you can be monitoring things like the temperature of your engine, the RPM. You can be measuring the amount of oxygen in your exhaust stream, for example. All kinds of things if you have sensors. So analog, that would be coming in. You convert it to digital. You use your program. So this would be programmed actually in the double EEPROM. Probably they do C now. When I was doing it, I was programming in assembly, which is a fun language to program in, but a little difficult to learn. And then on the output, what you have is you go from the digital world back to the analog. And so this would be analog outputs to actuators. So that is just a comment about what makes engines efficient, and embedded processors have really helped mechanical engineers significantly make the internal combustion engine very efficient. And that is what would be within one of these embedded processors, as I've drawn there below. So that concludes today's lecture. Thank you for your attention, and we'll see you next time. Thank you. Bye-bye.